Hello everyone, welcome to Weld6. As a welding engineer, I got some knowledge regarding to materials and metallurgy with respect to the exam point of view. But applying the theoretical concept into practical, it would be the best job for an application engineer. American Welding Society plays a vital role and it acts as a portal to connect both theoretical as well as the practical sector. As a welding engineer, I am so much interested to explore American Welding Society handbook. The video that I am being uploading, it is not meant for profit based or subscriber based or viewer based. It is just an hobby. The topic for video presentation is nickel and cobalt alloys, reference American Welding Society Welding Handbook, Chapter 4, Volume 5, Introduction. Yes, nickel and cobalt alloys provide unique combinations of physical and mechanical properties and exceptional resistance to corrosion attack. If the need for the extraordinary properties were not critical to a variety of industrial applications, these alloys probably would not be manufactured because of high cost. Is nickel and cobalt alloys is resistant to corrosive attack? The answer is yes. It is resist corrosive attack in various media at temperature up to 1100 degrees Celsius, which means 1100 degrees Celsius, and maintain good mechanical strength in both low temperature and high temperature environment. For use in the demanding service conditions, weld in nickel and cobalt must duplicate the attributes of the base metal to a very high degree. Thus, condition for welding, heat treating, and fabrication procedures must be established with these attributes included. High quality weldments are readily produced in nickel based and cobalt based alloys by commonly used welding processes, although not all processes are applicable to every alloy. Metallurgical characteristics or the unavailability of matching or suitable welding filler metals and fluxes may limit the choice of welding processes. Is welding procedure for nickel and cobalt based alloy is similar to stainless steel? The answer is yes. Welding procedure for nickel and cobalt based alloys are similar to those used for stainless steel, except that the molten weld metal is more sluggish, which requires more accurate placement of the weld metal in the joint. The thermal expansion characteristics of nickel and cobalt based alloy approximates both of carbon steel, but they are more favorable than those of stainless steel. Wrapping and distortion during welding is not severe. Is there is any relation between mechanical properties and amount of hot work or cold work in base metal? The answer is yes. The mechanical properties of nickel based and cobalt based metal vary depending on the amount of hot work or cold work applied to the finished form, that is sheet, plate or tubes. Some modifications in the welding procedures can be made if the base metal is not in the fully annealed condition. Next one is there is any option for PWHT? The property of welded joints in the fully annealed nickel and cobalt alloys should be similar to those of the base metal. Post-weld heat treatment is usually not needed to maintain or restore corrosion resistance in most nickel and cobalt alloys. Is all the nickel and cobalt based alloy is exempted from PWHT? The answer is no. Welds made in nickel molybdenum alloy B, UNS number N10001 and nickel silicon cast alloys are commonly solution annealed after welding to restore corrosion resistance to the heat affected zone. Rapid cooling from solution annealing temperature is necessary to avoid formation of detrimental metallurgical phases, which can have an effect on mechanical properties and corrosion resistance. How to deal with very aggressive corrosive environment? The only answer is filler metals that are more highly alloyed than the base metal are often used to fabricate components of service in very aggressive corrosive environment. The overmatching composition offsets the effect of weld metal segregation that occurs when a matching composition is used. Example, the use of nickel chromium molybdenum NiCrMo14, UNS number is N06686, filler metal to weld the superaustenitic stainless steel alloys, those containing 4% to 6% molybdenum, and alloy C276, UNS number is N10276, base metal. Post-weld heat treatment may be required for precipitation hardening also known as age hardening in specific alloys. Post-weld stress relief may be necessary to avoid stress corrosion cracking in applications involving hydrofluoric acid vapor or satin caustics solutions. For example, nickel copper alloy 400 UNS number is N04400 immersed in hydrofluoric acid is not sensitive to stress corrosion cracking but becomes sensitive when exposed to aerated acid or the acid vapors. Most of the commonly used joining processes are appropriate for nickel and cobalt alloys. The choice of welding process should be based on the parameters like the specific alloy to be welded, thickness of the base metal, design requirements of the structure, that is temperature, pressure and type of stresses, service condition and environment, even welding position too. These parameters plays a vital role for the choice of welding process.